All right, this video is to introduce you to a formula for the Richter scale invented by Charles Richter in the early 1900s. And this is what's used to measure earthquakes that we see like in the news. They'll always give a Richter scale rating. So as I said, Charles Richter invented it in the early 1900s. And he defined it using a magnitude. And we're going to represent magnitude with a capital M. And the way they calculate magnitude, or Richter decided to calculate magnitude, was to take the common log of the intensity of the earthquake. And when we talk about intensity here, this is coming from the idea of a seismograph, which is just a needle that scrolls back and forth across paper as it moves, according to time. When there's no earthquake, and that's what the capital S here represents, we call it the standard earthquake, and it has 1 micron of deflection, or that's 10 to the negative fourth centimeters. And so we're taking a ratio of what we see on the seismograph compared to what we call the standard earthquake. You take the common log of that ratio, and that's what gives us our magnitude. So let's take a look at how we might use this formula to solve a problem. The 1906 earthquake in San Francisco had an estimated magnitude of 8.3 on the Richter scale. And the reason we say estimated here is this is, of course, before Charles Richter invented the Richter scale. But based on damage assessments and everything and records, we estimate it to have been about 8.3. Then during Game 3 of the 1989 World Series in San Francisco at Candlestick Park, it was shaken by an earthquake measuring 7.1 on the Richter scale. So if our estimates are correct about the 1906 earthquake, it was more powerful. So what we want to know is how many times more intense was the 1906 earthquake than the 1989 event. All right, we want to know how many times more powerful, or how many more times as intense was it. We can tell by the Richter scale reading that it was stronger, but what does that really mean? I mean, 8.3 to 7.1, yes, they're both severe earthquakes, but how can we tell how many more times it's intense? Well, to do this, what we're going to do is we've got two earthquakes, so we're going to use that formula twice. So I'm going to start by writing an equation for both earthquakes. So I'm going to say, like, for instance, the 1906 earthquake. I'm going to work that over here. And then I'm also going to work the 1989 earthquake over here. And for this part of the problem, they're pretty much going to be worked the same way. We're just going to try and find the intensity for each earthquake because we're given the Richter scale measurement. So for the 1906 earthquake, I've got 8.3 is equal to that common logarithm of the intensity divided by that standard earthquake, and that was 10 to the negative 4 centimeters. All right, so 10 to the negative 4 centimeters. So when we find this intensity for both of these, we're talking in centimeters of deflection. For the 1989 earthquake, however, we have 7.1 is equal to that common log of the intensity here over the 10 to the negative 4th. All right. So both of these are common logarithms, and I need to solve for the intensity I. So my next step is once you have the equations down, is to go ahead and rewrite them in exponential form. They're the common logarithms. So for both of these, the base is going to be 10. So we'll have 10 raised to the 8.3 power. Logarithm's going to disappear, and we're going to have I divided by 10 raised to the negative 4th power. All right. Similar thing over here on the right for the 1989 earthquake. I have 10 raised to the 7.1 power is equal to I, or the intensity of that earthquake, divided by 10 to the negative 4th power. Now, I want to isolate the intensity I. So on both of these, what I'm going to do is I'm going to come along and multiply both sides by 10 raised to the negative 4th power. Right, 10 to the negative fourth power. There we go. And let's see, over here, I'll do the same thing, 10 to the negative fourth power on both sides. Now, if you remember when we reviewed our properties of exponents, we said that if we were multiplying two factors that had the same base and different exponents, we would simply add the exponents. And I forgot to mark over here. On the left, these will just simplify out. So when I do this, what's going to happen is I'm going to have, if I add these exponents, and that is a negative 4 there, it's kind of hard to see because it was on the line. That is a negative 4. But this thing is going to become 10 raised to the 4.3 power, because I'm going to have 8.3 minus 4. And that's going to give us the intensity of this 1906 earthquake. On the right, I'm going to have 7.1 minus 4. So this one's going to end up giving us 10 raised to the 3.1 power. And that's going to be equal to the intensity of the 1989 earthquake. And so now all we really need to do is go to our calculator, and we're going to evaluate. Okay, and we're going to get the two intensities. However, we're still not done at that point. So let's go ahead and get this one for the 1906 earthquake. So I got 10 raised to the 4.3 power. And it comes out that it would have a deflection of 19,952. I'm just going to leave it and round it there. So 19,953 centimeters, right, of intensity. That's how they would measure the intensity. That's the deflection on it. And then the intensity for the other earthquake is going to be 10 raised to the 3.1 power. So that's going to be 1,200 and let's call it 59, 1,259 centimeters. Now that's great, I've got those, but if you remember, our problem asked how many times more intense was the 1906 earthquake. So to finally answer the question, what I'm going to need to do is I need to go ahead and come back, and I'm going to divide these two. I'm going to take the intensity of the larger one, so I'm going to have basically the intensity of the 1906 earthquake divided by the intensity of the 1989 earthquake. And when I do that, I'm going to just do that all in the calculator. That's going to tell me how many times greater or more intense the 1906 earthquake was than the 1989 earthquake. So let's go ahead and take those values. So on my calculator, I'm going to come up, and I'm just going to use the numbers in the calculator. I know I rounded when I wrote them on the page, but it's not going to be far enough off to make that much of a difference. The rounding here. So I'm going to go ahead and divide these two, and we can see that the 1906 earthquake, I should say, was about 15.8 times greater. So we're going to record that as our answer. So it's about 15.8 times as intense. Okay. Now, in your practice for this, you're going to have a problem that's very similar to this one, just to practice the process. But there's also going to be a challenge problem that I would like everybody to try, where it's going to give you the Richter scale measurement for one earthquake and tell you that the second earthquake was so many times more intense than it. And it's going to ask you to find the approximate magnitude of that second earthquake. I would like everybody to try it, and we'll go over it in class once you've had a chance to try it. But that's it for the Richter scale.